All right, new day, new laptop to repair. This time we have a Dell G15-5530. This is a newer G-series laptop. It's like a 2024 model. The customer recently purchased this at Dell.com, and it came with 16 gigs of RAM, and they wanted to upgrade it to 32, so they added an extra 16 gig stick, and then the machine wouldn't turn on anymore. They took that stick back out, and now the laptop's still completely dead. So I haven't taken a look at this yet. We're gonna look at it together and see if we can get this figured out. I really like the look of this laptop. It's like a two-tone with some blue on the back, but when you press the power button, nothing's happening. Let's plug in the power meter and see what we see. So keep an eye on the power meter. Okay, it jumps up to 0.3 right when we plug it in, and it's not moving around. So we're at 0.30, 0.31. Let's see if we press the power button. All right, nothing's changing. Okay, so it is kind of strange. So when you plug in the charger, the normal operation would be it jumps up to 0.01 or 0.02, but sometimes it'll jump up to like 100 milliamps and then come back down to that. But this, when we plug it in, I'm just watching it. Look, see how it jumps straight to 0.31? That is actually pointing to some sort of shorted component that's persistently using that 6 watts, it looks like. So right when I plug it in, it does it. We'll do it one more time. Okay, so it went to 0.12 and then up to 0.31. Yes, this laptop's definitely not working right at all. It's not acting normal, so that means that I'm pointing to some sort of short on the motherboard, but we'll have to open it up and take a look inside. All right, and the bottom is off. Let's take a quick look around. Looks like we've got the main battery, Dell OEM. There's the wireless card. We got 1 stick of memory in here. Looks like 2 NVMe slots. There's 1 populated. This one's empty right here. A pair of fans. This is a newer machine. This says February 2023. It has DDR5 memory. So let's, I'm gonna unplug the battery. Let's do a CMOS reset real quick and see if it changes anything. So with the battery unplugged, I wanna see what the current draw is now. And it jumps right back to that 0.30, that 300 milliamps. Not good. It's not a good sign at all. Let me see where the voltage is going. Let's get under the microscope real quick. All right, we got it under the microscope here, and here's the DC in jack. So what I want to do is I want to measure and see how far the voltage is going. We are constantly pulling that 0.3 amps, which is not a good sign, and we want to figure out, oh, you can see somebody's been in here measuring. Look at that. There's scrapes across that. Interesting. I wonder if this was sent to another repair shop already. Ooh, the board kind of looks a little bit dirty, like it's been cleaned up. All right, we'll just gotta take notes of everything. Okay, so what we want to do first is measure the voltage coming out of the DC jack. And we can see we're getting our 20 volts. But it does go through some vias here onto the other side of the board, so I can't see where it's going. And if we measure this current sense resistor, we are getting 0.2, so we're not getting voltage over here. So it means most likely the main power rail is not being energized. This is going to be for the charging of the battery, so maybe the rest of the charge circuitry is on the other side. Oh, we have 20 volts over here actually. So maybe it's popping up through here. Going through these inductors, and then we have 5 volts over here. Yeah, but we can take a quick look around and see if we see anything obvious on this side, but we're gonna have to pull the board out. There's the LCD connector. And you can tell someone's been in here. You see how the sticky's all gone on this? So normally this should be stuck down, so somebody has opened this up plenty of times. So I'm not sure if it went to another repair shop. I haven't talked to the customer. So they were saying they were replacing the stick of memory, they were adding a second stick, and so after they did that, then the machine no longer turned on. Okay, that's really all we can see on this side. So let me pull out this motherboard and we'll continue. All right, let's look at the other side. Yes, so here's the input circuitry that we were talking about. So on this side, there's not very many MOSFETs. On this side, look how many MOSFETs are over here. So the way that these systems are set up is they have a lot of protection MOSFETs that will shut off the main power rails to protect the laptop from damaging itself. So if there is some sort of issue, what is going on right here? Okay, do you see that? So that's the EC chip and this is the BIOS chip. This looks like flux or something. Look at that. So maybe someone's been messing with the BIOS on this? It would be nice to get a lot more information about this. Let's see, the customer's note says, laptop was purchased from Dell.com, includes 16 gigs of RAM. I purchased another 16 gigs of RAM, so I can have 2 sticks of RAM, and it did not work. I attempted to reinstall the original, and it never came back on ever again. That's it. So I don't know. That's all the notes. They didn't say I took it to another repair shop. They attempted to fix it, things like that. All right, so there's something going on there. But anyway, back to these input MOSFETs. So what we want to look at on these input MOSFETs is we want to see if the current's making it all the way over and how far it's going. So I'm assuming that that side of the vias actually connects to the DC jack. So let's plug that in and we can measure. I'll have to flip this around here. Okay, so it's going to be right there. So we have our meter in voltage mode. And so the voltage is going to be coming out of the DC jack here, going through these inductors, and then it's going to go into these MOSFETs. And these MOSFETs, they just act as switches. There's a pair of them here. And so they have 4 pins going in, 3 pins going out, and there's just an on-off switch, more or less. So they will shut off if they're detecting any issues. So right now they are on. So we have the voltage going through there. Then it's going through a second set, and it's going through the 3 legs here. That's the on-off gate pin there. And then do we have voltage on the output? We do. So we have our voltage here. So that goes into the current sense resistor, which is being monitored by our power management IC. And the power management IC will detect if there's a current overflow or a current spike, and it will shut these MOSFETs off to protect it. Then it goes through, it looks like another set of MOSFETs. So we can say it comes out of here, comes over here. This one is coming to the middle, it looks like, and going through this inductor. And we still have our 20 volts there. And then this is probably the main power rail. Oh no, this is 3.4. So here's our 3 volt power rail. Interesting. So close to the 20. So here's our power management IC that we were talking about. And so this right here is what's in charge of turning on and off all these MOSFETs to protect the laptop. But all of this is working, so most likely this chip is working too. I see another current sense resistor here. Let's measure that one. We have 20 volts there. So it looks like the main power rail is energized. So we shouldn't see an issue with anything there. But we want to figure out what's actually taking this, looks like 0.29, 0.28. It was 0.30, so it's a little bit lower now that we have it out of the machine. So I guess it's whatever it was plugged into is not using as much current. But we don't know, right? So let's take a look under the thermal camera. I want to see if we see anything heating up. All right, I have the thermal camera set up, so we can take a look at that. So let me plug in the power and we'll just see if we see anything getting hot. All right, I do see a little bit of heat here. Let's see if it's a reflection. All we have to do is tilt the board. Nope, it's definitely something heating up in this area. But it looks a little diffuse, so it's probably on the other side of the board. But let's take a look at everywhere else first. Maybe a little bit of heat here. We tilt the board. You can see the reflection, so we have to tilt it. Maybe there's a little something here too. So let's flip over the board. Okay, so, oh, wow, look at that. So what is that? Okay, something's really hot, 212 degrees. That's like boiling point. So I'm gonna unplug this. So what is that? So to me, it looks like it's this chip right here, or it could be a component around it. Let me zoom in. All right, so I'm not sure what this chip is for. I'm guessing it probably powers the RAM. Since they were messing with the RAM. This capacitor looks a little suspect though. You see how it has like that marking there? So we could have a problem with that. I'm wondering if, oh, look at that. There's a burn right there on that resistor. Do you see that? So I'm wondering if a screw made it over here or something like that. Yeah, because you can see this mark right there. And there's like a mark on there. So let me remove our heatsink. And that way we can look at all the circuitry here, whatever's here. I'm not sure what it is, so let me get this heatsink taken off. Okay, we got the heatsink off. The chips are pretty dry except for this liquid metal that looks like it leaked out the side. I wasn't aware that this machine came with a liquid metal. So it does have a proper dam, but it looks like this was pressed down right here, which can make it where it can leak out. It was also pressed down here. I'm not sure why. This is also pressed down here. So this whole area, something is installed incorrectly. But yeah, I didn't know that this thing came with liquid metal. I don't think it does. Oh, it does. See, it says it right here. You guys know how I feel about liquid metal. So I'm going to clean that off and we're going to put some PTM 7950 on here instead. But here's what we wanted to look at. So we have it off now, and so we can see what this chip is. So this is the one that was getting hot, or this area. But we can see there's a mark here. There's some scratches on this, like someone's been measuring over here. There's a mark there. There's a mark on that. Yeah, so I don't know, but you can definitely see that something has hit this component right here. So this is a resistor, and maybe something hit here. It looks like someone was measuring right there. There's a mark there. There's scratches on here. And this is an inductor, so this is just going to pass current from one power rail to another. It helps smooth it out. There's something across that. So I don't know the exact story on this, but you know somebody's been in here messing with stuff. Let's plug in the power. I want to see what's getting hot over here. The way to isolate it, we're going to put some isopropyl alcohol on the board, and it will evaporate whatever's getting hot. So we'll just put that on there. And I'm going to plug in the power. And what do you think it is? It's that chip. So do you think that that chip is what's actually bad? It could be. But it also could be what it's powering. So we could start by replacing it. You know, another thing I'm just noticing, again, somebody's been in here. Look at the pins on this. It looks like someone's been measuring in here. It almost looks like some of these pins are almost shorted together. See, pin 1, pin 2, pin 3, pin 4, and pin 5, they all look like they've had somebody sticking a measuring device on there and then kind of scraping the solder over. And same with these pins here. And same with the pins on the backside. And so with that said, this chip's probably bad at this point, because if they were measuring with it on at any point and it slipped, then it would actually short out the chip itself. So we could reflow this just to see if we fix any solder balls underneath it, but I'm pretty sure this chip is toast. Now again, I don't know what it powers. It's a PUM. Could go to the CPU, but it could also go to the memory. Let me just reflow the chip real quick to see if it changes anything. And so by reflowing, we're just going to melt the solder and get it reoriented in the correct fashion. So we'll add a little bit of flux to it. And some hair, apparently. Flux is very sticky, so everything sticks to it. We have to get our air, safety air. I'm going to do 450 at 60% air. And what we're looking for is that we're going to try to get this solder to flow, so just keep an eye on it. There we go, we got this side going already. We've got a couple of those going. All right, there we go. So we'll let this cool off for a minute and then we'll continue testing. All right, so the chip is now cooled off. So I'm just gonna dry off some of this alcohol real quick. Trying to get the rest of the flux out of there. All right, so you can see how much better the pins look now. So let's plug it in and see if we get any different results. So keep an eye on the power meter. Jumped up to 0.27 still, and you could see on the thermal camera that it's up to 240 degrees, so it's getting really hot. So I'm going to say that this chip is bad, but we need to kind of look around and see if we see anything shorted on the outputs. So I'm going to do that before we just, jump to straight replacing that chip. So let's see what the output is. Let's measure it in ohms. So I'm putting the meter now in continuity mode where it beeps when you touch the probes together, and I'm just measuring on ground. Let's just check this. That's the input probably. Let's check this output. So we have a short right here. Okay, and that is coming up. Does it go to this power rail? Interesting. So we're showing shorted over here, or does this go to the CPU? All right, so what I want to do is I want to measure the output here, or even the input. And so if I measure right here, you can see that we're almost getting a dead short here. It's 0.3. And if we follow that up here, it comes and connects to this solder bridge. And so we're getting 0.2 right here. So that's basically a dead short. And what are we getting on this side? 33 ohms? No, 0.4. All right, so on a capacitor like this, we definitely shouldn't have a ground on both sides, because I'm measuring from ground to this point. And so that means that we do have a short across this rail. Now, whether it's this chip that's causing the short, I don't know. We could pull that chip off, and then that would relieve the short. But what I want to do is, you see how there's some vias right here? I want to look on the other side of the board, and I want to see if we have anything suspicious over here. We could have a cracked capacitor. We could also inject voltage in this area and see if we're getting anything. Because what I suspect is that it's not this chip that's bad, but this chip's trying to power something that's shorted out. So we don't know until we kind of look around a little bit. So let's flip over the board. And what is on this side? What's this? What's that? Is that cracked? Let's see if it's shorted over here. We have a short. If I measure on this inductor, This coil's shorted, so this power rail's shorted right here. To me, that looks cracked. What do you think? We'll zoom in real close. Or it looks like maybe someone measured on it. I'm suspecting, I mean, somebody's been over here doing something. Look at all these little marks on everything. Let's inject voltage right here. What do you think? Let's do that. We're going to set our voltage injection tool to something low. Since the resistance is very low, then we don't need super high voltage at this point. So 0.5 volt would be perfect. Let's inject it at that point and we'll monitor it on the thermal camera. All right, we will inject right here at this coil and just keep an eye out. You see anything getting hot? I hear it beeping, but I'm not seeing anything getting hot. So on this side, it's not one of these capacitors, which I was hoping for. Let's slide around a little bit. I don't see anything else. Let me flip it back over. And we know that this solder bridge was also shorted, so we're going to inject it right here now. And what do we see getting hot? CPU? The CPU's getting hot? Well, that ain't good. The CPU should not be that low, so I don't think we have a shorted MOSFET. Let me measure the MOSFETs on the CPU. So here's all the power stages for the CPU right here. We got 7 stages. This is why we keep the voltage low in case it does go into the CPU. So if we measure across the first stage, we're at 16 ohms. We're going to look for something that matches. Second one's 13 ohms. Third one's 13 ohms. 13 ohms, and then these should be lower. 13 ohms. 13 and 96, 97. So none of these are low enough, so I'm assuming this must power some sort of stage in the CPU, but I don't know what voltage is supposed to be here. That's the issue. We are putting 0.5 volt in, and it is pulling, how much are we pulling? We're pulling 2 amps. So whatever it is pulling 2 amps. The CPU is getting hot, but I don't see anything else getting hot. Let me see if I can measure if I see the voltage going into one of these coils by chance. Sorry for the beeping noise. Don't see any voltage coming out of that coil. And nothing coming out of that one. This is a head scratcher because I did not expect that this would actually be going into the CPU. Now there's a chance that someone got some liquid metal on something and it is shorting out. Let's do a quick physical inspection. So looking around would probably help. And I don't know if they knocked something off, because if they said that all they did was just change the memory out, then they shouldn't have messed with the CPU side at all. It would be on the memory side, which is the other side of the board. But since somebody else has been in here, there's measurements all over the place. There's evidence of flux. There's something going on here on the BIOS chip. I don't know if they thought it was a BIOS issue, and so they were messing with it. This is just sticky, so I think there was a cover here that never made it back on there. These are some power rails. Let's measure what these power rails are, but I guess it doesn't matter. If we plug it in and we know that that component's shorted, we don't need to keep it plugged in. There's the power management chip. So let's go back to the other side. This is the side that the person had been messing with by installing the RAM, and that's why I'm kind of thinking the other side would be more the issue. But we do see a short on this component. And the reason why I'm not thinking that this chip is bad is because we actually went past it, injected voltage on the other side of it, and it is heating up the CPU. And so we could have a short in the CPU, which I would love to know a cause, right? So, you know, cause and effect, if someone changed out memory, what would blow it out, right? You know, I have seen a model, one of these model, whoa, what's that? So something was ripped off of there. We don't know what that was. I can probably get a new board from stock and take a look at it. But what I was going to say is that I did have a machine that somebody was changing out memory on one time, and then they ended up trying to unplug the battery, and when they were trying to do that or something, it, like a screwdriver slipped and it went scrape and scraped off all these chips here, but they didn't notice it, and then they're like, I don't know why the board doesn't work. And so I had to go back and replace all these chips. So we do have something ripped off here, and I would love to see what that is. So let me go grab a donor board or a new board from stock, and then we can take a look at that component real quick. I'll be right back. Okay, I got a donor board here. So this machine, it actually works. It posts sometimes. The customer had dropped their laptop and I could never figure it out, but basically when they dropped it, I think it messed up some solder joints somewhere on the board, and so you can get it to post sometimes it doesn't post, and it's a strange situation. So I keep this board around so I can use it for measurements and testing stuff. But if you notice these stickers right here, there's no stickers across here. So whoever took this apart actually took all these stickers off too. So we're gonna peel this back and we can take a look and see what that component is. It looks like the layout's a little different though. And sometimes they do that depending upon what GPU is on here. All right. What area are we looking at? Right around here. See, this one has this component here and it's not here on here. This one has an inductor here and it's over there. So yeah, we don't have this piece right here, but we do have something similar on here. So maybe it's already supposed to be like that. So maybe it's supposed to look like that. Maybe that's just a test point. It does say CMOS next to it. Let's look around a little bit more. Or should I call the customer? I think I want to call the customer and get more of the story, and then I can report back. Yeah, let's do that. I'll be right back. All right, so I got the update from the customer. So he said that a friend of his was using this laptop abroad, okay, outside the United States, and I guess something had happened to it, and then his friend was trying to fix it. He wasn't aware that it was taken apart even to be fixed, and maybe it was taken to a repair shop. So the owner of this laptop doesn't know much more than that. So he was kind of surprised to know that it had been taken apart, and he did even apologize, because I told him, I said, you know, it makes it a little bit harder if somebody else has tried to fix a laptop. And so at this point, we don't really know what has been messed with. While we can see kind of like the BIOS and stuff, but the BIOS isn't going to cause what we're seeing here. But if we take into account that that one chip was measured in that certain way where all these pins were bent over and they were even touching each other, and we know for a fact that this pin right here comes up and goes into the CPU, he could have very likely shorted out those two pins while they were measuring that and then burned out the CPU. And that's kind of what I'm thinking has happened here. And at that point, this will be a no fix. But I'm going to give it more time, a little more effort, and we're going to see if we can kind of figure this out. I think what I want to do next is I want to take this chip off and see if we still have the short, which we should, but you know, that's just assuming because we injected voltage here, this was heating up. But if we take this off, we could see if this still gets hot or what gets hot, if something else gets hot in this region. We can also replace this chip. That is also another thing that we can try. That way we kind of do everything we can and not just give up really fast. So that's probably what we're going to do next. But let's take these stickers off, like I was saying, you know, because if they did come in here and they were measuring, there's a chance that there is liquid metal just around here, and I hate liquid metal. I've told you this a million times. So I'm going to pull off all these stickers. Let's go ahead and get it cleaned, and then we'll see if we can see if that's resolved, because it could just be a ball of solder underneath the CPU, but at the same time, that will ruin the CPU too. So let me go ahead and get these stickers off and we'll continue. So for those who don't know anything about the liquid metal, it's actually a gallium-based metal that's able to pull the heat off the CPU onto the heatsink very efficiently, but it also is highly conductive, so any drops that get on the board can actually cause a short, which is a downfall because regular thermal paste is non-conductive, and so it's actually safe. So I don't condone it, I don't like it, and it's become a mess on any of these high-end machines. Dell puts it on there from the factory, but then if you don't know how to work with it safely, then you'll end up damaging the machine. So that's why I don't like it. And normally they don't put it on the GPU, and it was actually on the GPU on this one, and this is only a 4060. This does not need liquid metal. So whoever put it back together added liquid metal. But you see how it's just balls here? Look at this. See that? It's just liquid, and it will stick to any of these components, and a little drop will get in here and you can't even tell it's here. It just looks like another solder ball, and it will short out different components. It also can get underneath the CPU. All right, I'm gonna get the rest of this off of here. All right, look at this. See, this is why I always check everywhere. I hate this stuff. Look at that. It's underneath the GPU right here. What about the CPU? And it doesn't take much, just like a little dot. Because the GPU and CPU, they're BGA packages, so they're actually sitting on balls. And an array of balls. And it doesn't take much for them to get shorted out. So I don't see anything on the CPU, but the GPU definitely has something there. Look at that. Now, I'm not saying that's what the issue is, but it doesn't look good. And it's going to be hard to get out of it. Oh, okay. I'm going to go put this in the freezer real quick because it's liquefied. So if I go put this in the freezer, then I can actually cool that off and I can probably flake it out real quick. So let me go do that. All right, the board's nice and cold now. Huh. Looks like it already fell out. So whenever you get it nice and cold, it gets hard and then it doesn't want to stick to what it's sticking to. So it is a good trick. There's still pieces everywhere. You know, I've spent 20 minutes trying to clean off this liquid metal, and it would have taken me like 20 seconds to clean off regular thermal paste. So we'll move on now. Now we can try to measure this again, now that we have this all cleaned off. All right, let's plug it in and see if we're getting any type of different measurement. Now that we took off the liquid metal, we'll see if there's anything shorting out something still. Okay, that's still, let's see if this chip's still getting hot. Ooh, ouch, that's hot. Let's remove that component. I just want to see what happens when we do that, see if we still have a short on that power rail going to the CPU. We know that what this is powering is not a main power rail, but I don't know what voltage is supposed to be there. It could be like 1.8 volts, it could be a 5 volt, I don't know, I have no idea. And I just want to measure it real quick before we take it off. So we are measuring in ohms mode, 0.1. I mean, that's like dead short. That's like me touching these two things together. See? That's why I'm surprised it's not a capacitor. But let me remove that real quick and then we'll continue. Okay, we got it off. Okay, let's measure it now and see if we're getting anything different. So we were getting 0.1 before here, and what are we getting now? 0.9, 0.8. So we are getting a little bit different measurement, but it still is pretty low. And it may just be because the board's hot right now that we're getting a different measurement. And the reason why I don't think this chip is actually the issue, remember I was saying that it's getting hot? Well, it's trying to power something over here that's shorted to ground. Now, if I injected voltage here and this was shorted, it would have backfed over here and then this would have gotten hot. So because it's the CPU getting hot, that's why I'm thinking we have a CPU issue. And I think that it has to do with someone shorting this chip out and sending the wrong voltage to the CPU. But let's plug in the board now. I bet we're not going to pull that 0.3 anymore. And we're not getting anything. So it's not pulling that 0.3 anymore because that chip is not hooked up anymore. And are we getting our voltage rails, or did it just shut off everything because it can't detect that chip? Sometimes it will do that too. I'm not seeing any voltage on those coils or that coil. Nothing there, nothing here. And we don't even have our 20 volts over here. So it's definitely have shut off the main power rails because it can't detect that chip. So it does need that chip in order to run. And so we could replace it with another one, but I don't think that that's going to be the issue. Now that we have the chip taken off, let's inject some voltage anyway, and we'll monitor it under the thermal camera one more time. So now it's actually doing 6 amps. That's even higher. So again, we're still at half a volt. So we may have liquid metal. Look, there's liquid metal right here. We may have a liquid metal situation. 6 amps, 5 amps. I can't, yeah, you can tell it's right here in this corner that's getting hot. Right in this very corner, so pay attention to that. Is that right? See, and I don't want to go up much higher. See, we're already putting 5 amps in there. So 95 degrees, but is that a reflection? Yeah, that is a reflection. Let's go back to the other side just to make sure that we're not getting anything on this side that we missed. Because the CPU has to be taking that 5 amps. Now 5 amps seems like a lot, but you know, we're only at a half a volt. So if you do the math on that, it's like 2.5 watts. I kind of want to clean this board. I may send this through the ultrasonic cleaner. That way we make sure that we don't have any liquid metal under anything, because we were able to clean out the liquid metal over here. Because it's strange. I had a machine the other day, and I'll post a video soon, but basically I had liquid metal on it, and I could hit the board like this, and if I plug it in, it will do something different. I'm interested to see if we're going to change the properties. It's still 5 amps. Now if I hit it the other way, it's because there's liquid metal just kind of rolling around under the CPU or on the board. 4 amps. Let's go this way with it. 5 amps, so nothing's really changing on that, so I don't know if that's going to be the case. I think this just has a dead CPU, and now how it happened, I don't know. You know, the guy's story, since he wasn't the one working on this, and so his original story was they were upgrading the RAM. That might be the story from the person who was borrowing the laptop, but I think it's more likely the customer was upgrading the laptop, maybe took it apart to put liquid metal on it, or took it apart to do something else, and then they ended up breaking it and tried fixing it. But I'll run this through the ultrasonic cleaner for one last ditch effort to see if we could resolve that short, then we'll continue. Oh, and before we continue, since we have our donor board here, and I know this board turns on occasionally, we at least can figure out what voltage is supposed to be here and figure out what we're actually supposed to be measuring. It would be nice to know that, right? Everyone's been questioning that. So there's that solder bridge, and if we measure in ohms mode across that, we should have 480 ohms, right? And that comes down to the same chip. So we do have a chip if we want to put it on there, but again, I don't think it is the chip is the problem. So 480 ohms. And on this side is going to be ground, right? Or what do we get? 5 ohms, 4 ohms, 3 ohms? Okay, yeah, this side's ground. So that's what we're measuring, ground on that side. But this side, we're measuring almost 0, or basically 0, dead short. So let's turn this board on. Let's figure out what voltage we're supposed to have right there. Okay, we got the meter in voltage mode. And let's measure right here. I'm just going to plug it in while we're measuring there. I just want to see what it goes up to. And 1.1 volts, 1.13 volts. And the CPU is getting warm. You can see it getting warm. So you can see that's part of the CPU circuit. And we're getting 0.8 on the rest of the coils around it. All right, so now we know definitively that we're supposed to have on that solder bridge, we're supposed to have 480 ohms. Or was it kilo ohms or ohms? I can't remember. And we're supposed to have 1.13 volts on that solder bridge. But what we're getting is 0. And 0 ohms and 0 volts. And it's coming straight out of the CPU. So there is a chance, like I'm saying, there could be some liquid metal on this. So I'll put this inside my ultrasonic cleaning machine, get it cleaned, and we'll set it out for tomorrow, and I'll continue. All right, so next day, and I put this motherboard through the ultrasonic cleaner. You can actually see how clean it is now. But the question is, did this customer damage this motherboard beyond repair? Because it's looking like that CPU is going to be shorted out internally, and there's nothing we can really do about that. All right, so the moment of truth, what we want to figure out is if it was just liquid metal under the CPU or not. And so let's measure right here. And it's still showing shorted. So that means conclusively that without a doubt, the CPU is bad. There's a short internally in there, and what I'm suspecting is that whenever the customer or whoever it was working on this, because again, it's not full transparency to the actual customer. He had loaned this laptop to somebody else that lives abroad. But whoever was messing with this, trying to fix the machine, and I don't know what the original fault was, but probably bridged a couple pins. And so whenever we were looking at this before, all those pins were actually bent over, and you could tell that someone had been measuring. And this pin right here is what goes up there and connects to the CPU. And so if they just bridged these two together, they would have sent a jolt to the CPU. So unfortunately, this is going to be something that I'm not going to be able to fix. We do have this motherboard in stock. It's a $600 motherboard, so that's a pretty costly mistake, but we'll be able to get that replaced for them. And I'd love to know your thoughts on this one, and thanks for watching.
I couldn't save this laptop.